Okay, so welcome, dear students, to another video lecture. And in this particular video lecture, we will be discussing on these two topics, structure and union. What is structure? How can we use a structure? And how to use the structure in C programming? And what is union? What is the comparison of union to structure and so on? So let's jump quickly to the C program for an example of a structure. With this, we will understand what is structure and how we can make use of structure. So if you look at this program, I have used something called as struct. So this is a keyword. So what is a structure? I'll read out the definition from the textbook. A structure is a collection of one or more variables of different data types grouped together under a single name. So note that it is for different data types. We have seen that arrays is a collection of variables of same data type. But suppose we have something under which we have different data types to be stored in. The structure is one of the powerful tool that you can use. Now coming to union, just a word, union, the usage of union is also similar to a structure, but the way in which it will operate is slightly different. So before going into union, we will understand the usage of structure with this particular example. So the first thing that we need to do is we need to define what is the structure. So this is an example of definition of a structure. So here I have defined a structure using the keyword struct. This is required, and this is the structure name. What is the structure that I am going to use? And inside this curly brackets, I have defined what all things are there in that particular structure called as books. So you can see that inside this structure books, I have defined a character, which is maybe a book name with 10 memory locations. So this is actually what? This is nothing but strings. And I have defined an integer which represent the number of pages in the book. And I have a float which is a variable representing the price of the books. So inside the structure books, I have book name, which is a string, pages, which is an integer, and float, which is price. And after closing this curly brackets, I need to put this semicolon. So this is important. So this is the way in which I am defining a structure. So this definition of a structure can be outside the main function, or it can be inside the main function. But the important thing is, before using a structure, we must define it. So I'll repeat it once again. The structure definition can be outside the main function, or it can be inside the main function. The thing is, before using the structure, we must define it. Okay, so here I have defined a structure called as books. Now, how to declare it and how to initialize the particular structure. Let's come to the main function. So this is the main function, and this is the way in which I'll declare the structure. So here also the keyword is struct, which is denoting that it is actually a structure. What is this books? So this books is actually, if you have noted, it is actually the name of the structure. It is not the name of the variable, but it is the name of the structure. So the keyword followed by the name of the structure and followed by the variable of structure. Whatever is the variable which is a structure. So once we complete this example, it will be clear. So I have defined, so you can give this any name, whichever name you want, you can give. So this is how we will declare a structure. Now I will initialize it. Suppose I'm initializing it like this. A is equal to, what is the first thing? It is a character. size 10. So it is actually not a character, it is a string. So I have defined it like this. So this is the way in which we can initialize a string, followed by the number of pages. So 25 is the number of pages in the book named Balarama. And what is the third member? So these are called members inside a structure. So in a structure books, the first member is book name, the second member is the pages, and third member is prices. So while initializing a particular structure with variable name, some variable name A, first we need to specify the string, which is book name, followed by the number of pages, which is an integer, followed by the price, which is a float. So this is an example. So similarly, you can consider different cases. For example, you can consider cars, you can consider the salary, you can think of different cases where you want to group something which are of different data types. So this is the way which I can declare as well as initialize a structure. Once we declared and initialized, suppose if you want to call or if you want to use any particular member of the structure, what I'll use is I'll use this dot operator. So a dot book name, what it will take to A is the variable of structure with structure name books. So a dot book name, so it is already declared. See, we have already declared that A is a structure with structure name books. So a dot book name will take you to that particular particular structure books, and the member that specifically we are looking for is book name. So a dot book name will get me the name of the book. What is this? We have defined it as a string. So the format specifier must be %s. So here I have given a printf. Name of the book is %s. So this %s will take the value from a dot book name. What is A? A is the structure variable of structure name books, and the member of that particular structure that we are calling is book name. So a dot book name will take the string Balarama. So what the first printf statement will print is name of book is Balarama. Similarly, what will be the second printf statement? It prints number of pages is %d. Why have used %d? Because a dot pages or pages, the member in the structure books is an integer. That's why I have used %d. So a dot pages will call what is A? A is a structure with structure name books. So a dot pages will go to the member, that particular member of the structure. Okay, so that is first two print statements. So similarly, what will be this print statement will do? Can you quickly tell? So printf / new line, price of %s is %f. So what is this %f? S, %s is a dot book name, and %f is a dot price. So what it will print? Price of %s, which is a dot book name, which is Balarama here. Price of Balarama is %f. What is this %f? So price of Balarama is 12.5. So these will be printed. So this is how you can use structure. So this is the structure definition completed by this semicolon. Struct is the keyword. This is the structure name, and inside this you need to define the members. The members can be of different data types. Now while using it, you need to first declare a particular structure of variable, any variable name, and you can call it like this. So let me try to run it for you. Execute, compile and run. Yeah, so you can see that it has printed the name of book is Balarama, the number of pages is 25, and price of Balarama is 12.5. Now suppose I'm defining the structure inside the main. So I am cutting from here and I am pasting it inside the main. Let's see what happens. So I have now defined the structure inside the main function, but before using the, or before declaring the structure itself. Now let me run it. Now you can see that the program has executed properly and it has displayed the same output. So that is the basics of structure, how to define it, how to declare it, how to initialize it, and how to use it in a program. Now how to store the data from outside. So this data I have stored it, declared or initialized it inside the program itself. Suppose I want these data from the user. Okay, so I'll take the next program, which is in similar lines. So I have a keyword struct followed by the structure name books. Inside this, I have defined the members, which are of different data types. Now, inside the main function, I have declared that A is the variable structure of structure books. We have seen this in the previous example. Now, I have asked the user to enter the book name, the number of pages, and price. So here we can use scanf. We can use scanf similar to the way we are using the other data types. So what is the first data type, or what is the first member data type? Book name. It is actually string. So scanf %s. Remember, for strings scanf we don't need to use ampersand, but for other cases scanf we need to use ampersand. So it is a dot book name. So what will happen is, whatever the book name entered will be stored in the variable a dot book name, the member book name. Okay, a is the structure variable. Similarly, the pages will be stored in a dot pages. I'm not explaining it further, and the price will be stored in a dot price. And I have used the three printf statements to print the name, print the pages, and print the price. So now let me quickly run it. What we are expecting is, we are expecting the user to enter these, and it will be displayed for you. So I'll run it. I'll press F9, and it has asked me to enter the book name. So I'll first enter the book name, Balrima. Now I need to enter the number of pages. Suppose the pages is 25 and the price is, let's say, 12.5, and I'm running it. I can see that the output appears. The name of book is Balrima, the number of pages is 25, and price of Balrima is 12.5. So this is how we can use structure to store the or group of data which are of different data types, and how we can store it in the members of a structure. So similarly, suppose I want to define another book. Okay, suppose comma B. What will happen is, we have defined another book. What will be B dot book name? It will be a second structure, and we can store that name, the number of pages, price, and so on. So we can have a big list like this. So this is how we can define a structure, initialize a structure, declare a structure, store the values in a structure, and print the elements from a structure. So this is the basic thing. Now coming to unions. So unions are exactly similar to structure in usage. So let me quickly take a note which says the difference between structure and union. So the using wise, it is almost similar. So maybe I'll go to an example and quickly illustrate that. So let's consider the first case. What is the difference? Oh, let me take the first example itself. So this is the structure example. So I'll put the structure outside the main block. So this is the first example that I have shown. Now, if you are using union, I said that the usage is almost same, or the usage is 100% same, but the way in which it executes is the difference. So in the case of union, instead of the struct, I'll use the keyword union. Here also, while declaring the declaring the variable, I'll use union instead of structure or struct. So that is the only difference in terms of program. So here I have a union with the name books with 3 members, the same as in the previous case. You can give different as well. And inside this main function, I have declared a variable a with union books, and I have given the uh, three members of that union books. Now, suppose I am running it. What we are expecting is to print the book name, the pages, and the price, but it will not be printed. Only the first thing will be printed out. Now let me try to run it, and the other things, it will be some erroneous value. So I have run it. You can see that the name of book is Balrama, but the other 2 things are something else. So there you need to understand the difference between structure and union. So in order to understand the difference between structure and union, here I have given a table of difference. So this taken from a website in internet. And one of the difference is the keyword. Here in structure, we have the keyword struct, but while in union, we have the keyword union. So that we have already seen. That is one difference. Now coming to the key difference, which is the size. So when a variable associated with a structure, the compiler allocates the memory for each member. The size of a structure is greater than or equal to the sum of sizes of its members. That means when we say inside the structure, if we have, say, let's say int, let's consider 2 data types inside the structure, say book, what was the, so int pages, int pages, and then we have float price. Okay, so these are the members that we have defined in the structure. And before that, we have, say, character 10. I hope you can see it. Book name. Okay, so these are the 3 members inside. Suppose these are the 3 members inside the structure. Okay. So what will happen is compiler will allocate. Suppose it is 1 byte for each, 1 byte for character. And let's suppose it is 2 bytes for a integer, and suppose it is 4 bytes for float. What the compiler does is, how many bytes of memory location will be required for character? So it is 1 byte for a character. So there are 10 characters. So we require at least 10 memory locations like this. Suppose I am naming it as 0, or let's say, let's start it from 1, 2, 3, 4, etc. up to 10. So these are the memory addresses that are. So this much memory location is required to store what? This much memory location is required to store character. Now, how many memory locations is required to store integer? We require 2 memory locations, right? So we have the 11th memory location as well as the 12th memory location. These 2 memory locations are allocated for what? Allocated for integer. Now, how many memory locations for float? We require 4 bytes for memory locations. So we require from 13, 14, 15, and 16. So 4 memory locations are required for what? Float. Okay, so in summary, while defining a structure like this, we require at least 16 memory locations. Okay, now coming to union, it is not like this. So that is what is, the case of structure is written here. When a variable is associated with a structure, the compiler allocates the memory for each member. So memory for each member will be allocated separately. and the size of structure is greater than or equal to the size of the members. Now, this will take a lot of memory. So if you are using a structure, and if you have, let's say, suppose we have, let's say, 4 different structure variables, then the number of the space allocated will be 16 into 4. So this much memory location is required. But in the case of union, you can read it here. When a variable associated with a union is declared, the compiler allocates the memory by considering the size of the largest memory. So the size of union is equal to the size of the largest member. So what union will do is, if we have the same case, let's consider the same case. We have character, integer, and float. It will only allocate the largest memory location. So what is the largest member here? Here we have a string which require 10 memory location, integer which require 2 memory location, and float which will require 4 memory locations. So which is the largest one? So the string will be the largest one. So it will only allocate 10 memory locations like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whichever is the largest one that requires largest memory location required, that will be the number of memory location allocated. Now, what about the other cases like integer and float? So the thing is that in the case of union, we can only initialize, and we can use only one of the variable at a time. Either we can use the string, or you can use the integer or the float at a time. So that is the thing. So this much space will be allocated for all the 3 members, because the largest one is character with 10 memory locations, and that much number of memory locations is allocated. And suppose we are initializing an integer. Integer is also initialized from the beginning, from the first. Since only 2 memory locations are required, these 2 memory locations are used for integer. Similarly, so as I said, we can use only one member at a time. So suppose we are using float, it will allocate from the beginning itself: 1, 2, 3, 4. This much will be allocated for float. So in total, it will only allocate the member with maximum size. Okay, so that is the key difference between structure and union. Now, so what will happen to the memory? In the case of structure, each member within a structure is assigned unique storage area of location as like this. But in the case of union, memory allocated is shared by individual member of union. Now, there are some more differences are there. You can read out those differences. It is because of these arrangement. In the case of structure, we can have separate locations, but it will take a lot of memory. But in the case of union, we have the memory location equal to the largest one. So what will happen is we can access different members in the case of structure. So structure is more versatile, I would say, but union, it reserves a lot of memory. It will reduce the usage of memory. Now let me switch back to the C program, and let me try to run this program. So even though I have initialized these 3 data types, as I said, only one data type will be stored, and that particular data type can be utilized. So I'll run it. So I have used union. So you can see that the name of book has appeared correctly, but the other 2 things are not the correct ones. So there are different ways in which unions will be more powerful, more useful than compared to structures. Anyway, this is the fundamental difference between structures and unions. So in this video, we have seen how to define a structure, how to declare a structure and initialize it, and how to access, how to call that structure in the main program, and we have seen the difference between union and structures. So with this, we'll stop. Thank you.